Hello friends, welcome to this session. Today we are discussing the twisting couple on a cylinder or a wire. Let us consider a solid cylinder or a wire of a length L and radius of cross section R be clamped at one end and twisted at the other. So by applying a couple through an angle theta about its axis, due to elasticity of the material of the cylinder, a restoring couple is set up in it, and that is equivalent to the twisting couple, equal and opposite to the twisting couple. A cylinder of rod of a material of a coefficient of rigidity eta, let its upper end be fixed and let its couple be applied to the lower end in a plane perpendicular to its length, twisting it through an angle theta that measured in the radius. In the positions of the equilibrium, the twisting couple is equal and opposite to the restoring couple. Let us calculate the value of this couple. Its upper end is clamped at and the other is twisted by applying a couple to its lower end in a perpendicular to its length. The rod is said to be under torsion. A reaction is a setup due to the property of the elasticity, and a restoring couple equal and opposite to the twisting couple is produced. All the particles in the lower ends are shifted through the same angle theta, but the linear displacement of particle near the rim is more. The solid cylinder consists of large number of coaxial hollow cylinders. Consider one such hollow cylinder of a radius x. This r is the radius of the cylinder, but here we are considering the hollow cylinder and the radius is x this side. Okay, each radius of the lower end is turned through the same angle theta, but the displacement is the greatest at the rim. So this side the displacement is maximum or greatest, and as we are approached toward the center, the displacement is minimum, and when it reaches to the O center, it's reduced to 0. Let AB be the line parallel to the axis before the cylinder is twisted. On the twisting, the point shifted B to B dash. Here, this is the line. A plane is there. Here we are twisting at this side. So B to B dash. Same here, when it applied the couple this side, it shifts to B to B dash. The line AB takes up the position A B dash, such that before twisting, if this hollow cylinder were cut to be along AB and flattened out, it will form the rectangular plate, that is the ABCD. But after twisting, it takes the shape of a parallelogram AB dash C dash D. The angle through which this hollow cylinder is sheared. So the shearing angle is maximum at this side and minimum at this side. So therefore the triangle become BAB dash is equal to phi. So we can write BB dash is equal to L phi. So L phi is nothing but, or we can say that BB dash is nothing but x theta, because some radian takes place, so it shifted at this side. So we get the phi is equal to x theta by L. Obviously, the phi will have the maximum value where x is the greatest. That is, the maximum strain is on the outermost part of the cylinder and the least on the innermost. समझो, अब अगर हमारा हाथ शोल्डर के साथ फिक्स है और उस हाथ को हम पाम के तरफ से उसको घुमा रहे, तो क्या होगा? We observe that the maximum displacement takes place at the palm side, where the shoulder is fixed. your hand is fixed at the shoulder side, so their minimum displacement takes place at the shoulder. So shearing stress is not uniform all through this. Similar way, here, although the angle of shear is the same for any one hollow cylinder, it is different for different cylinders, being the greatest for the outermost and the least of the for the innermost one. So we can write the modulus of rigidity is equal to shearing stress divided by angle of shear. This angle of shear is nothing but the strain. So we can write F by phi. So F is equal to N phi, then phi is the value is x theta by L. So we substitute it. So we get F is equal to N x theta by L. Now the face of this hollow cylinder is what? 2 pi x ds. X is the radius and dx is the thickness of that hollow cylinder. So face area of this hollow cylinder is 2 pi x dx. And hence the total shearing force on this area, what is it? 2 pi x dx into nx theta by L. So 2 pi x n theta by L x square dx, just x multiplied it. Then moment of this force about this axis OO dash of the cylinder, that is equal to this value. So we get 2 pi n theta x square dx x by L is equal to 2 pi n theta x cube dx by L. So integrate this expression between limits x tend to 0 and x is equal to r. So the total couple on the cylinder is integration 0 to r is equal r into 2 pi n theta by L x cube dx. This is the what? Total couple on the cylinder. Now just integrating it, 2 pi takes outside the 2 pi n theta integration 2 pi n theta by L. So integration 0 to r x cube dx. Then by solving it, we get the 2 pi n theta by L x raised to 4 by r. The limit is 0 to r. Then we get the value 2 pi n theta r raised to 4 by 4L. So 2 and 4 get cancelled. So we get pi n theta r raised to 4 by 2L. So this theta is radians. So if theta is equal to 1, then the twisting couple per unit twist of the cylinder or wire is pi n r raised to 4 by twice L. So this is the twisting couple per unit twist of the wire. Suppose we are taking the two hollow cylinder, and then the twisting couple per unit twist of the wire is pi n r raised to 4 by twice L. This C is called as the torsional rigidity of the material of the wire. Since twisting couple is numerically equal to the restoring couple, and this C is called as the restoring couple per unit twist. If the cylindrical rod is a hollow, having internal and external radii, that is R1 and R2, then the couple required to twist the rod through which an angle will be obtained by integrating the expression, that is the 2 pi n r raised to 4 theta by 4L. Then we get the pi n r raised to 4 by twice L, but in place of r we are writing the C is equal to pi n divided by twice L into R2 raised to 4 minus R1 raised to 4. Thus if we have the two cylinders, one is the hollow and another is the solid, then what happens? We get the value by comparing the twisting couple. Means one is the hollow cylinder and the other is the solid. Having the same length, mass and material are given, then the twist of the cylinder through the same angle, more torque will be required for the hollow cylinder than the solid one. That means the greater couple is required to twist the hollow cylinder. Thus hollow shaft can transmit larger torques for the same angle of the twist, and that's why in the automobile they are using the mechanics using the hollow cylinder, not the solid cylinder, because it requires more torque. It transmit larger torques. So I hope you understand the twisting couple per unit twist of the wire or cylinder. That twisting couple is always equal and opposite to the restoring couple. I hope you understand all these things. Thank you very much for watching this video. Thank you.